Joined now by Ben Hamner, data scientist at Kaggle. Thank you so much for being with us.
Thanks for having me.
If a non-programmer wants to get into data science, what is the first step they should take?
The first step I'd say to take isn't really to try getting into data science in the abstract sense, but to go with a very specific, concrete question or problem that they're interested in. So for example, let's say they're a big sports fan and they want to figure out what's made Duke basketball team successful in the past 10 years. Or they want to figure out what makes my basketball team more likely to win a game, or what factors influence winning that game. They can go and search online for a ton of different data that will be very valuable in helping to answer that question. For example, which teams won and lost different games historically, which players played in those games, the recruiting strategies these teams have used, and so on, and really start to drill down into more details about what factors influence this. And in the process of going through this investigation, they'll learn a set of skills that are very valuable and will translate to similar questions in a bunch of other domains. Or for another completely separate example, let's say I'm curious about what types of topics I'm emailing most often about and how long it takes me to respond to emails on various topics, since I spend an embarrassing amount of time in email. I can go through and download a history of all my email archives, then go and research something about language modeling or topic modeling, use that to extract what topics I'm talking about, then use those topics to help relate that back to my email response times, or I might find out that the shorter an email I receive is, the faster I respond to it.
Are there characteristics that are shared among Kaggle competitors?
There's a couple really key ones that are shared among Kaggle competitors. I think it's really informative to also look at the characteristics that aren't shared. Some of those are, we have a really diverse set of community. We have guys as young as high school students and as old as 80-year-old retired college professors. We have people from a lot of different backgrounds, tending on the more quantitative side, but for example, that studied physics or electrical engineering in college, the usual suspects for those that studied statistics or machine learning or computer science. And we also have a bunch of others like glaciologists or weather scientists, or the occasional English major. So neither of those backgrounds really, or factors really, lent directly to a successful Kaggle participant. The characteristics that we see successful Kaggle participants really having are they tend to be very creative and very tenacious, while being able to ask quantitative questions, then handle the answers they get very well and make decisions based on those answers. So for example, when people are participating in one of our contests, they'll constantly be formulating hypotheses and asking questions. What makes this question more likely to be closed in Stack Overflow? What factors might influence how a teacher grades this essay that I can then use for my automated essay grading algorithm? And then a lot of the times the factors or hypotheses they're formulating end up not having an effect. But even if they're finding one that improves their performance 1 out of every 10 times or 1 out of every 20 times, if they're being very creative, asking a bunch of different questions that cover a broad variety of possible features and domains, and then evaluating their performance, they'll show a continued improvement over the problem. And that's what it really takes to do well in.
Interesting. Are there common mistakes that people new to data science make? I'm thinking things like overfitting and stuff like that.
Yeah, overfitting is definitely a common one that people make when they're actually participating in our contest. I guess it's important to realize that once you put a competition up at our site, that supervised machine learning problem is only a small component of data science. Then where we see a lot of the mistakes are actually earlier on in the process, or in the problem formulation or problem definition stages. So, for example, let's say I was asked to, this is one thing that had come up early on, looking at data sets to try identifying some of the causes of prostate cancer. One of the features in that was prostate cancer surgery, which was naturally, if they'd had prostate cancer surgery, it was strongly informative of whether or not they'd had prostate cancer. But that's not the type of feature I'd want to include in a model for predicting prostate cancer. And there's an interesting analysis done over a couple years ago over about 50 different machine learning contests that have been hosted in academia. About half of those had actually had some sort of problem along the problem formulation stage or the data leakage component.
So last question for you. What is the natural level you feel for democratized data science? I mean, do you feel like a level of that skill set will apply to virtually everybody, or is there a certain technical skill set that's going to have to be involved and it's going to level out at a certain point?
I think being fluent in working with numbers and quantitative is one of the basic skill sets that's going to be required regardless. But beyond that, I think kind of the history of computer programming and software development is really informative here and can apply here as well, because if we look at very early on, you had to work with an algorithm, you had to be soldering transistors to a circuit board. Then time progressed, advancements were made, and you could start programming by writing an assembly language. Then as more time progressed, languages like C came about and made programmers more productive. So each generation of programmers started operating at higher and higher levels of abstraction than the generation that came before them. Then we're seeing very similar trends emerge in data. So as each new generation of tools comes out and services comes out, it lowers the barrier of entry, makes it data science more easily accessible to a broader audience. And we expect that trend to continue very strongly. And if we look at most of the problems or questions in the world, a lot of them can be answered using data across a huge variety of domains. So we really expect to see the same trend of software eating the world with a lot of older domains to apply to data as well.
Well, thanks so much for being with us. Appreciate you taking the time.
Thanks a lot, Matt.
Okay,